So this activity is talking about the equations of parallel and perpendicular lines. And before we look at that, let's just talk a little bit about slope. So here I have some examples of positive, negative, zero, and undefined slopes. Let's just graph these lines really quick so that we can see what they look like. So for this example, I can see that my y-intercept is -5. So I'm going to start at -5. And my slope is 2/3. So I'm going to go up 2 and over 3. 2 is my rise and 3 is my run. So now I have 2 points and I can graph my line. And so this is an example of a positive slope. As it goes from left to right, it goes up. For my next example, my y-intercept is 2 and my slope is -3. I'm actually going to write that as a ratio, -3/1. You'll see why in a minute. Let's start out by graphing our y-intercept. I'm just putting a point at 0, 2. And then we're going to go down 3 and over 1 for our slope. That's why I wanted to write it over 1. So there we go, down 3 and over 1. Now I have 2 points and I can graph. And there's our line. As it goes from left to right, it is descending. It's going down, and so we say it has a negative slope. Y equals -2 is really easy to draw. You just put your point at 0, -2, and then draw a line straight across. That's y equals -2. Just pretend that's a straight line. We say this has a slope of 0 because it doesn't go up or down. It goes 0 up, it goes 0 down. It's just flat. If you tried to ski down this hill, since it's not a hill at all, you would be going 0 miles an hour. How about x equals 3? Well, I'm going to put a dot at x equals 3. So at 3 on the x-axis, I'm putting a dot. That point is 3, 0, right? If I were to graph the equation x equals 3, I would want to plot points at every single ordered pair where my x value was equal to 3. So that would be like all of these, right? So x is always equal to 3 for this equation. So basically I end up with a vertical line that crosses through 3 on my x-axis. We say this has an undefined slope. Why is that? Well, our rise is basically infinite. It goes up and down forever. But what about our run? Well, it doesn't run at all. So our run is 0. In other words, we're dividing by 0 and we're not allowed to divide by 0. It cannot be done. So since that cannot be done, this is an undefined slope. Straight up and down. So there's a quick little review of slope. Let's talk about the slope formula. So here's our slope formula at the top of our page, and we have 2 points here. The first thing we ought to really do is label them x1, y1, and x2, y2. So notice on this first point, both my x and y coordinates I'm considering to be 1s, x1, y1, and on the other point, they're both 2s. So now let's substitute these values into our formula. Subtracting my y's, I end up with 2 minus 4 in my numerator. And subtracting my x's, I end up with 2 minus -1 in my denominator. So simplifying this, I have -2 in my numerator, and 2 minus -1 is the same thing as 2 plus 1. So that's 3. So this is a slope of -2/3. You could actually see that in the graph without using the slope formula. Check this out. If I go 2 down from this point and 3 over, I end up at my next point. So my rise was -2 and my run was 3. That's another way to find the slope from a graph. So now we're ready to talk about parallel and perpendicular lines. Parallel lines never intersect and they have the same slope. Here's an example down here. Those 2 lines are never going to cross. So 4 points have been drawn on these lines, and we can use those points to calculate the slopes of the line. First, let's do our top line. Using our formula, we can see that the slope of that line is 1/2, or 1/2. Next, let's do the bottom line. Once again, we end up with a slope of 1/2, and that's why these lines are parallel. They have the same slope. So how about perpendicular lines? They intersect at a right angle, and they have opposite reciprocal slopes. Well, what does that mean? That means that the product of their slopes is -1. So let's look at this example and see exactly what that means. Let's do this line that I've just highlighted in red first. The slope of this line that I've highlighted in red is 1/3. Now let's try the other one that I'm highlighting in blue. The slope of this line is -3/1. Now check out what happens if we multiply these slopes together. We end up with a numerator of -3 and a denominator of 3, which simplifies to -1. That's what makes them opposite reciprocals. The opposite part refers to one being positive and the other being negative. The reciprocal part means that if you were to flip them upside down, one would turn into the other. So 1 over 3, flip it, becomes 3 over 1. So now you know how to recognize parallel and perpendicular lines. Let's use that knowledge to find the slopes of these lines. I've highlighted the slopes for all of my lines on the left. Since parallel lines have the same slope, I know that my first line has a slope of 2/5, my next has a slope of -3, and the next line has a slope of 4. Well, what about the next one? It says y equals 2. Do you remember what the graph of y equals 2 looks like? It's just a horizontal line that goes through 0, 2. So it has a slope of 0. So a slope of any line parallel to that is also going to be 0. That was a little bit of a trick question, wasn't it? Well, how about the next one? It's x equals -5. That would be like a straight up and down line like that. And we say that has an undefined slope. So in this case, we would say undefined or no slope. Both of those would be accurate ways of answering that question. Now, how about perpendicular lines? Once again, we really only need to look at the slope of our equations. We don't need to worry about the intercept or any of the rest of it. But this time we want to find the opposite reciprocals. So for 2 over 5, I'm going to write 5 over 2. Now I had a positive 2 over 5, so I need a negative 5 over 2. Here I have a -3. Well, that's a whole number. Well, it's an integer. I really want a ratio, so I'm going to write a denominator of 1. That'll make it easier. It's hard to figure out how to flip 3, but 3 over 1 is much easier. I know that this reciprocal would be 1 over 3. 3 over 1, the reciprocal is 1 over 3. Now this was a -3 over 1, right? So that means I want a positive 1 over 3. I don't need to write the positive sign, but I just wanted to point out this is positive because my original slope was negative. Okay, now the next one we have a slope of 4, and remember that's really a slope of 4 over 1. So the reciprocal of that slope would be 1 over 4. Since it's a positive 4, I'm going to want my slope of my perpendicular line to be a -1/4. That's the opposite part. All right, now we said y equals 2 has a slope of 0. Well, what would be perpendicular to that? Let's go back to our diagram. Remember that a slope of 0 gives us a horizontal line. A vertical line would be perpendicular to that. And vertical lines have undefined slopes. Similarly, when we have the example x equals -5, we know that's a vertical line. What's perpendicular to a vertical line? That's right, a horizontal line, and horizontal lines have slopes of 0. Can you figure out the next 3 here? Why don't you pause the video and hit play when you're ready to see the answers. How'd you do? I bet you aced it. Well, one thing I just want to point out here, this is a common trick that you might see on tests. We have -3/4 and we have +3/4. Those are not perpendicular because we don't have a reciprocal. If we had -3/4 and +4/3, they would be perpendicular. They're not parallel because they have opposite signs. One is negative and one is positive. So the best we can say about these is neither. They intersect, but they're not parallel or perpendicular. What about looking at our diagrams here? Are these diagrams showing parallel, perpendicular, or neither? Well, the first diagram shows a pair of parallel lines. The next diagram shows lines that intersect at a 90-degree angle. They're perpendicular. And the third shows us lines that are neither. They intersect, but they're not perpendicular. Before we move on, I want to tell you about one special case here. Now, looking at these two equations, do you notice anything, that stands out about them? One thing that stands out to me is if I multiply each term of the first equation by 2, I get the second equation. In fact, watch what happens if I rewrite these two equations in y-intercept form. Oh my gosh! I get the exact same thing for both equations. They are the same line. If I were to graph them, they would have the exact same graph. So these equations do not represent parallel lines. They don't represent perpendicular lines. They represent the same line. If you want to be really fancy, you might say that those are coinciding lines. But coinciding is just a fancy word for the exact same thing. So just know that that can happen too. All right, so let's look at how to write equations of parallel and perpendicular lines. This first example tells us to write the equation of a line parallel to y equals 1/3 x minus 10 that goes through the point 310. Whew, one step at a time. First, let's find the slope. Well, the slope of our original line was 1/3, and we want a line that's parallel to that, so our slope of our new line will be the same. Parallel lines have the same slope, so our slope will be 1/3. What about the y-intercept? Well, I'm going to write the slope-intercept form of a linear equation, and that's y equals mx plus b. I actually know x and y because we were given a point. We were given x and y. So I'm going to replace y with 10, and I'm going to replace x with 3. And what about m? Well, I know m. m is 1/3. What I don't know is b. I have an equation here that's pretty easy to solve, and if I solve it, I'll know what b is. I can see that 10 is equal to 1 plus b, which means that b must equal 9, because 1 plus 9 equals 10. So now I'm going to rewrite this. I'm going to write y equals mx plus b, but I want this to be true for all points, not just the one I was given. So instead of substituting x and y, I'm just going to leave x and y. What I am going to substitute into this equation are my slope and my y-intercept, which I now know is 9. So this is the equation of a line that is parallel to the one I was given that goes through the point 310. Why don't you pause the video and try it with the next example? How'd you do? I hope that you got it. If you didn't, take a look at the steps and figure out what went wrong. Next, let's try a perpendicular line. So for this one, I see that my slope is -2, and I want the opposite reciprocal of -2. So just remember, there's really a 1 in that denominator. What's the reciprocal of 2 over 1? 1 over 2. And since I want the opposite reciprocal, I want positive 1 over 2. Now, we want it to go through the point 4,8. So we're going to use the same procedure as before to find our y-intercept. So we know our slope is 1/2. Substituting the point 4,8 into the equation with our slope of 1/2, we realize that our y-intercept is 6. So we can write y equals 1/2 x plus 6. Why don't you pause the video and try the next example on your own? Push play when you're ready to see the answer. That one was a little bit tricky. Here's a little reminder on how to multiply fractions, just in case you need that. And now that we've multiplied our fractions, we can see that our final equation will be y equals -9/2 x plus 16. Notice that each of these 4 problems we did used the same steps. First, we found the slope, then we found the y-intercept, and then we wrote the equation. You can use those 4 steps to write the equation of any parallel or perpendicular line when given a point and when given another equation.